Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're continuing our discussion on radicals by looking at the Pythagorean Theorem. Now, I'm not going to spend too much time in this video going over the Pythagorean Theorem. That's for another video. But assuming that you know the Pythagorean Theorem, and I have it on the board, a squared plus b squared equals c squared for a right triangle in which the lengths of the sides are a, b, and c. We're going to solve two problems in this video with the Pythagorean Theorem. And they tie into radicals and equations with radicals because ultimately we deal with radicals basically in the final steps of the problem. So we have a problem here. I have a right triangle where the length of side A is unknown. Let's leave that variable A. The length of side B happens to be 6, and I wrote that it looks like a B, but it's a 6. And side C is 10. So all we're going to do is substitute the numbers in for the variables in the Pythagorean theorem like this. A squared stays A squared because that's our unknown for now. 6 in for B, which becomes 6 squared. And 10 in for C, which becomes 10 squared. Now we're just going to apply the squares to all the numbers that we can. So rewriting a squared, 6 squared is 36, and 10 squared is 100. And now we're going to try to isolate the term a squared, and to do that, we're going to subtract 36 from both sides. And when we do that, we get a squared is equal to 64. And the radical comes into play here because when we have a squared term on both sides, to get rid of the square, we take the root that's the same as the power. Since this is squared, we're going to take the square root of both sides. The square root of 64 happens to be a perfect square. The square root of 64, we would normally say is plus or minus 8. But since we're dealing with real space, we can't have a negative length, so we're going to keep the positive only number. So the answer for this is a equals 8. Now, just to point out that in this problem, one of the sides, either A or B, was the unknown. In the next problem that we're going to do, the side C is going to be the one that's unknown. And the way that we do the problem is we started the same, but the final steps are just going to be a little different. So let's take a look at that in a second. Okay, so I have another problem on the board, and if you notice here that the side A and length of side B are the same, so my picture is not perfectly drawn to scale, but the values of A and B go into the proper places. And in this case, C is unknown. So let's fill in to the Pythagorean theorem. Four in for A, 4 in for B, and C is unknown. So we have 4 squared plus 4 squared is equal to c squared, and 4 squared is 16. So let's put that in for both. And now we can combine the like terms. 16 plus 16 is 32. And since we have c squared, but we want c, we're going to take the square root of both sides. And the square root of c squared becomes c. But then we have equal to square root of 32. I'm going to write that over here because we need to do that. We need to simplify that a little more. 32 is not a perfect square. So what we're going to do is, and I did go over this in a previous video, we're going to factor the 32 into any factors that are perfect squares, and then any remaining factors that are not perfect squares. So if you think of 32 as divided by 16 and 2, can factor that into 16 times 2, and by the product rule for radicals, we can basically do the reverse of that and split them up. So if we did that, it would look like this. And you don't always have to write that step, as long as you understand that you are going to take the square root of the perfect square, which is 16. That's going to come out as plus or minus 4, but since it's in real space, we're just going to keep the positive form, which is 4. And then the square root of 2, which is not a perfect square, we leave that in its radical form as square root of 2. So the answer is the length of side C is 4 square root of 2. So anyway, that concludes this video, this short video on doing the Pythagorean Theorem. Thanks for watching, and I'll see you in the next video, where we're going to look at imaginary numbers and complex numbers.